Hello there and welcome to Learn Extra. In today's lesson, grade 10s, we are going to be having a look at functions. Now, functions is a really important section because you will meet functions this year, again in grade 11 and again in grade 12. So it's really, really important that you are happy with the basics. So listen very carefully. What we're going to be having a look at today is firstly just our definitions and terminology. What is a function, what is a straight line graph, and so on. Then we will be going through all the functions in the grade 10 syllabus, and those are the straight line graph, which you have already met in grade 9, the parabola, the hyperbola, and the exponential function. So we'll be talking about the properties of these different functions, and thereafter we're going to have a look at how to sketch them. Very important that you are able to form a mental picture of what your graph must look like and put it down on paper with the correct points and everything shown. Once we are comfortable with the sketching of the graphs, we're going to have a look at combination type questions. Combination type questions are questions where we might have a parabola and a straight line, or two exponential functions, and those are the sorts of questions that will typically make their way into your exam paper. Right, without any further delay, let's get going. Firstly, we need to know what a function is. Now, have a look at our definition over here. It says that a function is a mathematical relationship between two variables, x and y, where every input value, usually our x, has one output value. Now, there's a relatively easy way to check whether a graph that's presented to you is in fact a function. And we call that the vertical line test. Now, what I'm going to do is I'm quickly going to draw a couple of graphs. Firstly, let's draw a straight line graph. That's a straight line graph. A parabola. And a circle. Now, the vertical line test, to check whether it is in fact a function, you will take your pen and you will place your pen parallel to the y-axis. At any one point, if your pen only intersects the graph once, then we are dealing with a function. So have a look. Nowhere does it intersect more than once. Here's the intersection at the bottom. That's a function. Again, the parabola passes the vertical line test because at any given point, there's only one y value for every x value. The circle, however, is not a function. Have a look here. My pen intersects the graph at two distinct places, so therefore a circle is not a function. So very important when we're dealing with a function, do the vertical line test. Only one value for only one y value for every x. However, here at this particular x value, I have got two different y values. So that is how we know that we are dealing with a function. Now remember, the straight line graph, the parabola, the hyperbola, and the exponential are all functions. Right. So let's have a look then at some further definitions. Firstly, let's have a look at the domain. It says here the domain of a function is a set of all the independent x values for which there is a dependent y value. Basically what that means is the domain is all of the x values for which our graph is sketched. Then we also have the range, and the range we are dealing with the y values. So domain, range, domain and range. Right, now let's just have a look at a little bit of set notation. Right, let's have a look here. We are told X is an element of R where X is greater than 0. That means the set of all X values such that X is an element of the sets of real numbers greater than 0. So real numbers greater than 0. Remember, real numbers can be fractions. Right, so that's what this set notation means. Have a look at the next one. The next one deals with Y, and it talks about N. Now, N stands for natural numbers. And it says here, remember, you place yourself where the Y is. If I look that way, I see the open side of the inequality. So it says Y is greater than 3. Y is less than or equal to 5. In words, the set of Y values such that Y is a natural number greater than 3 and less than or equal to 5. So greater than 3, so the first natural number greater than 3 is 4, and then the next natural number is 5, and we are allowed to include 5 because it says less than or equal to 5. Right, now what does this Z mean? Z means an integer. So integers are numbers such as -5, -4, -3, -2, 0, 1, 2, 3, 4. So it's kind of like the natural numbers, except that now I am also including the negatives. Little bit of interval notation. What does it mean if I say 3 with a round bracket, semicolon, and then 11? That means that I am not including the 3. So remember, if I had to put this into set notation, this would be, well, we're assuming it's X, greater than 3, less than 11. So greater than, but not greater than, and equal to, less than 11, but not equal to 11. This one says from negative infinity to -2. So if I had to write that in set notation, that would be X less than -2. And that will then carry on into infinity. Right, now what if I have a square bracket? Over here, I've got a square bracket around the 1 and a round bracket around the 9. That means that 1 is included. In other words, if I had to write it in set notation, that means X greater than and equal to 1, less than 9. So very important, remember, round bracket does not include, square bracket does include. Right. We've spoken about the domain now. We said the domain is the X values. Then there's the range, and the range is the Y values. So the range is a set of all dependent Y values which can be obtained using an independent X value. What does that mean? Well, have a look over here on the left-hand side. I have X values. If I substitute X equal to -2 into the equation f of X equal to 2X, my Y value is -4. -1 substituted into the place of X, -2, and so on. So domain, range, independent and dependent. Right, so as I said to you guys earlier on, we're going to sketch straight lines, parabolas, hyperbolas, and quadratic equations, which are the parabolas. So straight line, which is a linear function, and parabolas, which is a quadratic function. Now, it's very, very important to remember that if you are looking for the place where your graph intersects the x-axis, you will make y equal to 0. So if you want the x-intercept, what you will do is in the place of y in your original equation, you will put a 0 and then solve for the equation. If you want a y-intercept, you will make x0. And this goes for all the functions. So you don't have to learn anything separately. Let's start off with our straight line function. Our straight line function has got the general equation y is mx plus c. Some of you might be familiar with. Alternatively, we can also write it as y is ax plus q. Now let's have a look at what the different variables do. M stands for the gradient. So the gradient is the slope of your graph. M determines whether your graph will run downhill from left to right, whether it will run uphill from left to right, and also how steeply your graph runs uphill or downhill. So, if m is greater than 0, your graph will run uphill from left to right. If m is less than 0, in other words, we have a negative gradient, your graph will run downhill from left to right. If m is equal to 0, your graph will be parallel to the x-axis, like so. Okay? Right. So it's very important before you sketch a graph, or even if you're trying to calculate the equation of a graph, to have a good mental picture of what you are expecting. If you are doing a calculation on a graph with a positive gradient and you sketch the graph and it's not going uphill from left to right, you need to go back and check where perhaps you made a mistake. Then just some properties of straight lines. Of course, we know that parallel lines have equal gradients. So parallel lines never intersect and their gradients are equal. Perpendicular lines, those are lines that intersect at a 90-degree angle. If lines are perpendicular, they intersect at a 90-degree angle, and something else is true. The gradient of the one graph multiplied by the gradient of the other straight line will give you -1. So the gradients are the negative inverses of each other. In other words, if the one line's gradient is 2/3, the gradient of the line perpendicular to that line will have to be its inverse, which is 3/2, with the opposite sign, a minus, so that when I multiply these together, I get to -1. Right. Now, the other one that we need to have a look at is C. Or it could be Q. They could even call it K or B. It really doesn't make a difference. Now, C or Q is the y-intercept of your straight line graph. So in other words, if I have a graph y is equal to 2x plus 4, 4 is my C value, and I then know that my graph intersects the y-axis at y equal to 4. So here it says, gives us a little summary. If C or Q is equal to 0, in other words, if there is no Q or C value, then our graph will have a y-intercept at the origin. If C is bigger than 0, our graph will have a y-intercept on the positive x-axis. Alternatively, if it's less than 0, the y-intercept will be on the negative y-axis. If we just have a look at y is mx plus c. If I start out with a straight line, y is equal to x. Okay, so if x is 1, y is 1. If x is 2, y is 2. And I then ask you to sketch for me y is equal to x plus 1. What that means is my basic graph y is equal to x has been shifted 1 unit up, so that now its y-intercept is 1. If I then say sketch for me y is equal to x minus 4, for example, it means that my basic graph y is equal to x has been shifted down by 4 units. Right. Now, let's quickly have a look at a summary of straight line graphs. If we have a look at our first picture over here, this is a graph with a negative gradient. It's running downhill from left to right. Its C value is bigger than 0 because its y-intercept is on the positive x-axis. The next graph has got a gradient of 0 because it is parallel to the x-axis. This graph over here has a positive gradient and a C value that's obviously greater than 0, once again because its y-intercept is on the positive y-axis. This graph has got a C value of 0 because the graph has a y-intercept at the origin. Also, its gradient is negative because it's going downhill from left to right. Positive gradient, C value 0. Negative gradient, negative C value. 0 gradient, negative C value. And positive gradient, negative C value. Right, let's get on with it because the straight line graph generally isn't our hardest one. There are several different methods that you can use to plot a straight line graph. Now, by the time you get into grade 10, it won't be too prescriptive which method you have to use. You were taught, however, in grade 9, the table method, the gradient intercept method, and the dual intercept method. Now, in my opinion, the easiest one to use is the dual intercept method. With the dual intercept method, what you will be doing is you will be getting the X-intercept and the Y-intercept, and you will be connecting those lines. So let's have a look at how to sketch y is equal to 2x plus 4 using the dual intercept method. Firstly, I have a look at my C value, and my C value is 4. That gives me the y-intercept, so my y-intercept, 3 over there at 4. Remember, it's very important to indicate that point. It's also important to label your axes. Now, to get the x-intercept, what I need to do is I need to make y equal to 0. So I'm going to say 2x plus 4 equal to 0. So 2x is minus 4, so x is minus 2. And I'm indicating that on my graph as well. And then using a ruler, my ruler is letting me down here. Wait. Maybe I'm letting the ruler down. Let's just have a look. I'm rather going to do it freehand. And there I've sketched the line y as 2x plus 4. Now remember, it's very important to look at the properties of the graph. I could see that my gradient was positive, so I expected a line that went uphill from left to right. I could also see that my y-intercept was above the y-axis, so this graph looks exactly like I would expect it to look. Let's quickly have a look at another one. Sketch the graph of the following, and we have got y minus 3x equal to 0. Now this one is a little bit different. Firstly, I'm going to say y is equal to 3x. What I've done is I've taken the minus 3x to the other side of the equation, and it became positive. Now, this graph has a y-intercept at the origin. Why do I say that? Because there is no C value over here. Or I could see it as y is equal to 3x plus 0. So this one I will have to do a little bit differently. Right. The x-intercept and the y-intercept of this graph is 0. If I make x equal to 0, I get y as 0. If I make y equal to 0, I get x is equal to 0. Now, that means I have only 1 point. So I have no idea how steep my graph must be. Now, in this case, it would be a good idea just to calculate 2 points, and that's with the table method. So I'm going to say, okay, right, let's have a look at a couple of values for x. You can draw a table, and I'm going to say my equation is y is equal to 3x. So let's start with x equal to negative 2. If x is minus 2, then the corresponding y value will be negative 6. And let's take a positive value as well. If x is 2, the y value will be positive 6. Now I'm going to put these values onto my table. So let's just count in 2s, and I'm going to say, right, if this is minus 2, then the corresponding y value is minus 2, minus 4, minus 6 over here. So that's the point negative 2, negative 6, and let's do the positive point as well. Let's make this x is 2. Then the y, corresponding y value will be 2, 4, 6 over there. And now I'm just going to connect those 2 points. I now know exactly how steep my line needs to be. And I'm drawing a straight line in between the two. And please note that it goes through the origin. So remember, dual intercept method in general would be our best method. However, if you have a graph y is equal to ax, in the form y is equal to ax, with no c value, both your x and your y-intercept will be the origin, and that's not going to work because you won't know how steeply to pitch your graph. Then rather do a table, get 2 values, and make very sure that your graph runs through the origin. Right, let's have a look at our next example. 2y is equal to 4 minus x. I'm first going to put the equation into standard form. I prefer to have the x first. That's just a personal thing. Remember that y needs to be the subject of the equation, so I'm now going to divide the entire equation through by 2. So y will then be negative a half x plus 2. In this case, I can happily use the dual intercept method. I'm going to say clearly my y-intercept is at 2. I'm going to mark that on the y-axis. And now I'm going to solve for minus a half x plus 2 equal to 0. Right. Minus a half x equal to minus 2. Multiply through by minus 2, and I get x is equal to 4. And 1, 2, 3, 2, 3, 4. And quite simply connect those. Obviously, you will do so using a ruler. Right, guys, the straight line graph is not a difficult one. I don't think we should spend too much time on it because there are harder things that we need to deal with. So we'll visit our straight line graphs again a little bit later on when we have a look at our combination questions. We're going to take a short break and we will be back with you shortly. Welcome back. Now it's time for us to look at our parabola or our quadratic function. Right. So our general equation for a parabola is y is equal to ax squared plus q. We should all by now know what a parabola looks like. It's either a smiley face or a sad face. Now let's talk briefly about the effects of a and q. Firstly, if a is positive, if it's greater than 0, the graph has a minimum turning point. In other words, it goes down to a minimum. It's a smiley face. And the turning point will be at x is 0 and y is q. If a is less than 0, in other words, if the coefficient of x squared is negative, our graph will have a maximum turning point, so that would be like a sad face. Right, so it's important to know how the value of a affects the shape of our graph. Guys, if a is between 0 and 1, in other words, if a is a fraction, my graph will become wider. However, if I look at an a value of, let's say, 2 and an a value of 3, an a value of 3 will be steeper and therefore narrower than an a value of 2. So important to just have that idea in your head. If I have a graph y is equal to a half x squared, That'll be on the outside. Then x squared will be on the 1x squared will be on the inside. 3x squared will be even narrower on the inside again. Then finally, let's have a look at that value q. Now, as with all other functions, the role of q is to shift your graph up or down. So if q is bigger than 0, your graph will be moved up from the origin. If q is less than 0, your graph will be moved down from the origin, right? So q deals with the vertical shift of the graph. Another bit of terminology that we need to talk about quickly is the axis of symmetry. Now, the axis of symmetry is that line that we can draw where the two halves of the graph are exactly the same. And for now, in grade 10, our axis of symmetry will be right down the middle on the y-axis. So the axis of symmetry is x equal to 0. So all of our graphs will be symmetric about the y-axis. Right, guys, if we have a look at this first graph, it is a sad face, which means that A is negative. Its turning point, however, is on the positive y-axis, so it means that q must have been greater than 0. Here, I have a positive a value because my graph is smiling. I've also got a positive q value because the graph has been shifted upwards. In other words, it has a turning point on the positive y-axis. For a graph where q is equal to 0, like for instance, y is equal to x squared. There's no q value, so your graph turns perfectly on the origin. And this is obviously a graph that would be like y is equal to minus x squared because of the fact that it is an upside down smile, a sad face. This could be something like y is equal to positive x squared because it's a smiley face. If I look at the final two graphs, this graph could be something like y is equal to minus x squared minus 2 because the graph has been shifted down. And this graph could be something like y is equal to positive x squared minus 2 because the graph has been shifted down also. Right, let's carry on with sketching parabolas because that's where graphs really start getting interesting in my opinion. The first question asks us to sketch the following function, and it says y is equal to x squared plus 3. Y is equal to x squared plus 3. So now what do I expect? That's the first thing. I like to make a little rough sketch on the side just to make sure that I know what's happening. The first thing that I expect is a graph that has got a smiley face. Why do I expect a smiley face? Because the coefficient of x squared is positive 1. I also expect that the graph has been shifted upwards because the q value is positive 3. So I'm expecting something like that. Now, we do have to indicate some points on our graph so that we can get the gradient of the graph correct. So well, I'm going to start off by saying, right, the turning point of this graph will be at 0, 3. Remember, the turning point is at 0 and whatever the value of q is, and the value of q in this case is 3. So x is 0, y is 3. That is where my graph is going to turn. Now, I can clearly notice that this graph is not going to intersect the x-axis, okay? Just from what I think the graph is going to look like, it's not going to intersect the x-axis, but let's have a look quickly why. What do we do if we want to get the x-intercept? We make y equal to 0. So if I say x squared plus 3 is equal to 0, that becomes x squared is equal to minus 3, and then x would be the negative square root of 3, and that's an imaginary root. It doesn't really exist, so it's not going to intersect the x-axis. So I sit now with the problem that I don't have more points, and so I won't really know how narrow or how wide I must make my graph. Now, similar to the straight line graph, remember when we had y is equal to 3x? It just went through the origin. What did I do there? I drew up a little table just with 2 other points that I can show on the graph so that I know that I've got the graph correct. So I'm going to do this. I'm going to say, right, let me substitute in x is minus 2. Let's do minus 1 rather. If I substitute minus 1 into the place of x, I get minus 1 squared, which is 1, plus 3, which is 4. And I'm going to use the symmetrical point on the other side, so I'm going to use x is equal to 1. Again, x is equal to 1 is substituted into the equation. 1 squared plus 3 is again 4. So now I have 2 other points. So I'm going to say, right, with x equal to 1, that's over here, just minus 1 and 1. With x equal to 1 goes y equal to 4. With x equal to minus 1. With x equal to plus 1 goes y equal to 4 as well. And then I've got an idea as to how I should connect my graph. Remember, guys, for a parabola, you won't be using a ruler. You have to draw it in a curved fashion because that is what the graph will look like. Let's have a look at our next example. Y is equal to a half x squared plus 4. Right. Again, I'm forming a mental picture. Firstly, I'm going to have a happy graph. Why? Because a half is a positive value. Again, it's a happy graph that has shifted up from the origin. So I'm going to have a similar situation to my previous graph. I already know that my graph will not intersect the x-axis. So once again, I'll have to use a table to get some extra values on there. So we know that our graph always turns at x is 0, y is q. So q value is 4. 1, 2, 3, 4. And I'm going to choose some values to substitute into the place of x. What I'm going to do this time is I'm going to use minus 2 and 2. So if I substitute minus 2 into the place of x, it is minus 2 squared. I can in fact show you. It is minus 2 squared, which is 4. 4 times a half, which is 2, plus the other 4, and that is 6. So x is equal to minus 2 goes with y is equal to 6. And similarly, because the graph is symmetrical around the y-axis, if I change that to plus 2, I'm going to get 6 as well. Connect my dots with a curve, and there I've sketched the graph. Right, next example. Just as I expected, our next example is going to be a graph with a negative a value. So let's just quickly form a mental picture of what we are expecting. The fact that the coefficient of x squared is negative 2 means I'm going to have a sad face. But it's negative 2 plus 4, so it is a sad face that is shifted 4 units up from the origin. So something like this. Sad face, but with a turning point on the positive y-axis. Right, so the first thing that we do is we fill in the turning point. That is 0 and q, and again q is 4. So 1, 2, 3, 4. Now, this graph, if I look at my rough sketch, I can see that this graph is going to have X-intercept. So I don't have to use a table like I did previously to get extra values. I can just calculate the X-intercepts, and I do that by putting y equal to 0. So I'm going to say minus 2x squared plus 4 is equal to 0. So minus 2x squared is equal to minus 4. So x squared is 2, so x will be plus and minus the square root of 2. And I'm just going to indicate it on my graph. Well, it's more than 1, so it'll be there. Negative root 2 and positive root 2. And again, connecting the dots. Remember also, name the y-axis, name the x-axis. So really, you guys should see that sketching a parabola is not as difficult as you might think. Now, we'll visit the parabola again a little bit later on when we combine all our different types of functions. The next function on the menu for today is our hyperbola. And the hyperbola has the general equation y is equal to a over x plus q. Once again, we're going to have a look at what is the effect of a and what is the effect of q. Right. If a is positive, in other words, a greater than 0, my graph will lie in the first and the third quadrant. So like that and like that, if a is positive. However, if a is negative, my graph will lie in the second and in the fourth quadrant. So A determines which quadrants my graph lie in. That's the first thing. Now what about, well, let's talk a little bit more about A. If A is bigger than 1, the graph will be further away from the axes than the basic graph 1 over x. If A is between 0 and 1, the graph tends to 0, and it moves closer to the axes than y is equal to 1 over x. We will see that just now when we draw the graphs. And once again, for a less than minus 1, the graph will be further away from the axes than y equal to minus 1 over x. In between minus 1 and 0, the graph tends to 0, so it moves closer to the axes. That might be a little bit difficult to understand at this point, but we will definitely be able to see that when we start sketching the graphs. Now, let's have a look at the effect of q. Up to now, for the straight line graph, what has q done? It shifted the graph up and down. For the parabola, what has q done? It shifted the graph up and down. Now, surprise, surprise, for the hyperbola, rather, what does q do? It shifts the graph up and down. So, a q bigger than 0 means that the graph will be shifted vertically upwards, and q less than 0 means that the graph will be shifted vertically downwards. Right. Let's have a look at our first example. Now, a hyperbola has something very important that we're only dealing with for the first time this year, and those are asymptotes. Now, asymptotes are imaginary lines that my curve gets closer and closer and closer to, but it doesn't touch. Now, for this year, our one asymptote will always be the y-axis. So the y-axis will always be an asymptote, and that is a vertical asymptote. Vertical meaning it goes down. So the equation of the y-axis is actually x is equal to 0. So why can x not be equal to 0? Well, let's have a look at our equation over here. I've got y is equal to 16 over x. Now, do you guys agree that if I substitute 0 into the place of x, that expression is undefined? So, definitely your graph cannot have the value x is equal to 0. So, therefore, the y-axis will be an asymptote. My other asymptote, my horizontal asymptote, like the horizon, will be at the value of q. Now, q is how much my graph is shifted upwards or downwards. Now, in my first equation that I'm asked, or my first graph that I'm asked to do, I don't have a Q value, so I just want to, it's 16 over X plus 0. So therefore I know that my horizontal asymptote is going to be on the x-axis. So let's do our little rough sketch firstly. So what am I expecting? An asymptote x is equal to 0 always. The horizontal asymptote is whatever the value of q is. In this case, q is 0. So the x-axis will act as my horizontal asymptote. Then I need to look at my value of a. 16 is a positive number, so therefore I know that my hyperbola will lie, I meant to do it over there, in the first and in the third quadrant. Now, that is the basics that I'm expecting. Now what I need to do is I need to plot a couple of points to make sure that I'm doing this accurately. Now, you guys are allowed to use the graphing function of your calculator to get a table with x and y for yourself. That is absolutely allowed. However, you can also just make a little table yourself, which is what I'm going to do. I'm going to make sure that my table includes negative and positive x values. So let's see. Starting off with x is equal to minus 2. If x is equal to minus 2, I substitute minus 2 in the place of x. I get 16 divided by minus 2, that's minus 8. If x is equal to minus 1, my y value is minus 16. Then obviously I know that at x equal to 0, my graph is not defined. That's an asymptote. So I'm going to do x is equal to positive 1, y is positive 16, and then again x is positive 2 goes with y is positive 8. Right. So let's see. I'm going to have to change my scale quite a bit. So I think I'm going to count in 4s on my y-axis. I'm going to say 4, 8, 12, 16, and I'll keep the scale on my x-axis the same because it will fit in. So when x is equal to 1, y is equal to 16. When x is equal to 2, y is equal to 8. You could have even taken another, preferably a factor. It just makes life easier. If x is 4, y will be equal to 4, so maybe do that. 1, 2, 3, 4. And connect the dots. Over here, it looks like my graph is about to intersect the asymptote, so I'm just fixing that quickly. Like that. And this graph will then be identically mirrored in the third quadrant. Right. So that's pretty straightforward. We have to determine where our asymptotes are, and then to get the gradient of our graph correct, use either the tabling function on your calculator or just come up with a table yourself. It's always easier to use numbers that are factors so that you don't end up sitting with confusing decimals. Right. Now let's have a look at our next graph. My next graph is y is equal to 3 over x plus 4. So again, what I'm going to do is I'm going to do a little rough sketch. Okay. Firstly, I know that my vertical asymptote will always be the y-axis. So I'm going to fill in my asymptote there. Then, this plus 4 over here means that now my horizontal asymptote is at y is equal to 4. So my horizontal asymptote is going to be at y is equal to 4, like that. My a value is positive. So therefore, my graph lies in the first and the third quadrant. And something else important I need to see here is that my graph will intersect the x-axis. it will intersect the x-axis, so I will need to find the value of that x-intercept. For the x-intercept, I make y equal to 0, so I say 3 over x plus 4 is equal to 0. Okay? Then 3 over x is equal to minus 4. I'm now going to multiply my equation through by an x. So let's do that. Times x times x. X's cancel and I get minus 4x is equal to 3. So x is negative 3/4. So if I have a look, so I know that at x equal to minus 3/4, I will have an x-intercept. Right. Again, especially with something like this that gets a little bit more complicated, it isn't a bad idea to use the graphing function on your calculator to come up with some values. So let's just clean some space. And what I'm going to do is mark x is equal to negative 3/4 on my x-axis so that I know that I have an x-intercept over there. Next thing I'm going to do is indicate my asymptotes, the y-axis, as I said to you guys before, and 1, 2, 3, 4. I think I'm going to count in twos, so I'll do that 2 and 4. We usually use a dotted line to indicate the asymptote. Right, let's get on with drawing a table. Remember, guys, if you're doing a table, it does help, as I've said before, to use things that give me whole numbered answers. So I'm going to start off using x equal to minus 1. If I substitute x equal to minus 1 into this equation, I get 3 divided by minus 1 plus 4, which is 1. Then I'm going to use x equal to minus 3. If I substitute minus 3 in the place of x, I get minus 1 plus 4, which is 3. Then x is equal to 1, we'll go with y is 7, and x is equal to 3, we'll go with y is equal to 5. So let's get on with the business of plotting these points. X equal to minus 1 goes with y equal to 1, so that's over there. Remember, I'm counting in twos. X equal to minus 3 goes with y equal to 3, so that's over there. And I can connect these going through my x-intercept, which was 3/4, like that. Then up to the first quadrant, with x equal to 1 goes y equal to 7. So I went 2, 4, 6, 8. So x is equal to 1 goes with y is equal to 7. X is equal to 1, 2, 3 goes with y is equal to 5. And there, oops, take care not to look like you're intersecting your asymptote. There I have it. Right, so asymptotes, number 1. Number 2, do a rough sketch and see if there's x-intercepts. If there are, calculate them. And then table function so that you can indicate some points on your graph. Right, let's have a look at the next question. Y is equal to 2 over x minus 2. Now, again, I have a hyperbola, and again, my vertical asymptote will be the y-axis. Now, this minus 2 means that the graph has moved down 2, so I will have, at minus 2, I will have my horizontal asymptote. The value of a is positive, so the graph will lie predominantly there and over here. From my rough diagram, I can also see that my graph does, in fact, intersect the x-axis, so it's important that I show that point on my graph. Guys, whenever there's an x or a y-intercept on any type of function, there won't be y-intercepts this year with a hyperbola. You have to show the intercepts with the axes. Right, so I've got an idea of where I'm going and what my graph is going to look like. I'm going to start by putting in the asymptotes. And let's use a dotted line. There's my horizontal asymptote. Not that we're going to see it, but the y-axis is my vertical asymptote. Now I need to calculate where my hyperbola intersects the x-axis, because from my rough sketch I could see that there was an x-intercept. So 2 over x minus 2 is equal to 0. So 2 over x is equal to 2. Multiplying through by x, I get 2x is 2, so x is 1. So I have an intercept with the x-axis at x equal to 1, and that seems to be consistent with the sketch that I had earlier. Oops. That's my y-axis, that's my x-axis. Now I'm going to do my table. Starting off with x equal to minus 2. If x is equal to minus 2, then I have minus 1 minus 2, which is minus 3. If x is minus 1, I have minus 2 minus 2, which is minus 4. If x is equal to 1, I have y as 0, which is consistent with my x-intercept that I've just calculated. And if x is 2, I'll have 2 divided by 2, which is 1, minus 1, which is minus 1. Right, and on with the business of sketching. This one will fit in nicely on my scale. X is minus 2. Y is minus 3. 1, 2, 3. Over there. X is minus 1. Y is minus 4. So that's over there. I'm going a little bit off my page, but that's okay. Right. Then in my first quadrant, let's have a look. If x is 1, y is 0, I've already got that point. If x is 2, y is minus 1. Let's do that one. And there we go. There is our hyperbola. So guys, if you bear in mind the shifts, and I think especially if you do a little rough diagram beforehand and you have some sort of a mental picture of what it is you're working towards, that will be your biggest chance of success. I don't have anything against using the table function on the calculator. That is wonderful. However, you cannot just put values into the table function of your calculator without having some sort of a mental picture of what your graph is going to look like. So what I would recommend, rough diagram, determine the asymptotes, determine intercepts with the x-axis if there are, and then do a table on your calculator to give you some extra points to put onto your graph. Right, we have only one more type of graph left that we have to do, and that is the exponential graph, and then we will have a look at the mixed type of questions. At this point, we're going to take a quick break so that you guys can digest all the information and be fresh when we return for exponential graphs and then some questions. Right, and last on our menu for functions grade 10s is our exponential graph. So let's have a look at the general equation for our exponential graph. Y is equal to a times b to the power x plus c, and I'm actually going to change that to plus q because we've been working with q all along. Right, so let's have a look at what we expect the different a, b, and q to do for us. Right, the first thing is, with an exponential graph, we have a horizontal asymptote. A horizontal asymptote like this, and the horizontal asymptote will be the line y is equal to q. So if your graph has 3 as a q value, there will be a horizontal asymptote at 3, meaning that the graph has shifted up 3. If your Q value is -3, the graph will be, the horizontal asymptote will be below the x-axis. So very, very important that the horizontal asymptote is the line y is equal to q. Now, the value of a, let's have a look at where a is in our equation, over there. The value of a determines whether our graph is above or below the asymptote. If a is positive, the graph is above the asymptote. If a is negative, the graph is below the asymptote. Then finally, let's talk about b. Now, b determines the direction of the curve. If b is bigger than 1, the graph will start close to the asymptote and curve further away from it, like so. If b is between 0 and -1, the graph will start further away from the asymptote and come closer to it. So those are the two options that we need to consider. Right, let's have a look at some examples. Firstly, let's have a look at the first graph. This graph over here has got a Q value of greater than 0. That means that the graph has moved above the x-axis. Have a look. There my asymptote is on the positive y-axis. Right. Then let's talk about the value of a. Remember I said the value of a determines whether your graph lies below or above the asymptote. A for this graph must be negative because my graph is below the asymptote. A for this graph must be positive because my graph is above the asymptote. Let's have a look at our next scenario. Our next scenario, Q is less than 0. And I know that because my horizontal asymptote is below the x-axis. The value for A must be less than 0 because my graph is below the asymptote. The value for A must be greater than 0 over here because my graph is above the asymptote. Now, for all of these graphs, I can say that B must have been greater than 1. Why? Because they all start off close to the asymptote and move further and further and further away. Right. Now, let's have a look at a similar scenario where B is between 0 and 1. I just want you guys to look at this again. If you look on the x-axis from left to right, my graph is going further away from the asymptote. Now, have a look at these examples. As I look at the curve from left to right, my graph is coming closer and closer and closer to the asymptote. Right. First example. Q must have been positive because my vertical asymptote is above the x-axis. A must have been negative because my graph is below the asymptote. And I can see that B must be between 0 and 1 because my graph is coming closer to the asymptote. Similarly, over here, I've got a positive Q value because the horizontal asymptote is above the x-axis. My A value must be positive because my graph is lying above the asymptote, and so on. So that's very important to remember. Q determines the asymptote. A positive A above the asymptote, a negative A below the asymptote. B bigger than 1, your graph will go further away from the asymptote as you look from left to right. If B is between 0 and 1, your graph will come closer and closer to the asymptote. It's very important that we know these properties because if we look at an equation of a graph, we can immediately visualize what the graph will look like. Alternatively, if we are given a graph and asked for the equation, we know what values we are looking for A, B, and Q based on what our graph looks like. Let's get on with the business of sketching some graphs. As before, guys, I'm first going to do a rough sketch, have an idea in my head of what I'm looking for, and then you can use either your own table or the graphing function of your calculator. Let's start off by looking at this graph. We've got y is equal to 3 to the power x plus 2. So this is clearly an exponential function. I'm going to write it in the form y is equal to 1 times 3 to the power x plus 2. Now let's first have a look at the effect of that plus 2. That plus 2 means that the graph has been shifted vertically upwards, and therefore my asymptote is going to lie on the line y is equal to 2. So I put that in first. Now I need to quickly calculate my y-intercept. I know the asymptote is at y is equal to 2, but let's calculate the y-intercept. So to calculate the y-intercept, I'm going to make x 0. So I'm going to say y is equal to 3 to the power 0 plus 2. Of course, 3 to the power 0 is 1, and 1 plus 2 is 3. So my graph will cut the y-axis over here at 3. Now, guys, please note that my a value is 1, and my graph will be increasing from left to right. The bigger the value of x, the bigger the graph. So I'm going to start out close to the asymptote at the y-intercept, and my graph will be increasing as I look at it from left to right. So guys, again, important, rough sketch, do the table, and you shouldn't have too many problems. Okay, let's have a look at our next example. Our next example is y is equal to minus 4 plus 2 to the power x. Now, what I'm going to do immediately is just rewrite it in a form that's more comfortable for me. Y is equal to 2 to the power x minus 4. So what am I expecting? My asymptote will be below the x-axis, and it will be at minus 4. I am expecting my graph to be above the asymptote and moving further and further away from the asymptote. So that's very important. If I look at that rough sketch over there, it means that this curve has both an x and a y-intercept, which actually means that perhaps the table is not necessary. Right, so let's get on with the business of calculating the x and the y-intercept. For the y-intercept, I'm going to make x equal to 0. So y is equal to 2 to the power 0 minus 4. That is 1 minus 4, which is minus 3. And let's indicate that on our graph. 1, 2, 3. I'm going to have to count slightly differently. So we're going to squash things in a little bit here. So at y is equal to minus 3, I have a y-intercept. Then at y is equal to minus 4, an asymptote. I'm doing a solid line just because you guys can't see the dotted line on here. There we go. Right, now I need to calculate my x-intercept. Don't forget to label your axes. For my x-intercept, I'm going to make y equal to 0. So I'm going to say 2 to the power x minus 4 equals 0. So 2 to the power x equals 4, which is 2 to the power 2. So x is 2. And that looks about right. Over here at x equal to 2, and there's my curve. It's going further and further away from the asymptote. Remember to show the values of your asymptote and your intersect with the axes. Right, guys, I think at this point in time, we are now getting ready to do some questions where all of the graphs are combined. Very important that you know your basics and that you have a mental picture of what it is exactly that you are looking for. Right. The first question that we're going to do deals with what do I do if I have a sketch and I'm asked to determine the equation of the graph. And we're going to go through those quite quickly. The first question says, given the general equations y is mx plus c, this is a line, y is ax squared plus q, that's a parabola, y is a over x plus q, that's a hyperbola, and y is b to the power x plus q, that's exponential. Determine the specific equations for each of the following graphs. Right, now very clearly, this is a straight line graph. So I'm going to write down that I'm looking for y as mx plus c. Okay, now I don't know how many of you actually use this equation, but I find that most people do best if they use this equation to find the equation of a straight line. The first order of business is going to be to calculate the gradient of the line. It's very clear that it goes through the origin. So, gradient formula. y2 minus y1 over x2 minus x1. Let's start over there. Minus 6 minus 0 over minus 2 minus 0. And the gradient of the graph is therefore 3. Now, does that make sense? Well, yes, it does. The graph is going uphill from left to right, and it's going uphill rather steeply. Now, it is very clear that this graph's y-intercept is the origin. So y is equal to 3x plus 0. I don't even need to use that formula, or just y is equal to 3x. Pretty straightforward. Let's have a look at the next one. Again, we asked to give the general equation, and this is what we have over here. And this is clearly a parabola, so I'm going to write down the general equation for the parabola. Y is equal to ax squared plus q. Now, guys, remember, q indicates to us how much the graph has been shifted upwards and downwards, and clearly this graph's turning point is at 3, so therefore q is equal to 3. So I'm going to say y is equal to ax squared plus 3. That much I know so far. The next thing that I need to calculate is the value of a, and for that I'm going to use the point given to me on the graph. X is 1, y is 1. So 1 is equal to a times 1 squared plus 3. And that gives me an a value of -2. So therefore, the specific equation for this graph is y is equal to minus 2x squared plus 3. As easy as that. And that is 100% consistent with what I see. I know that because I've got a non-smiley face, I was looking for a negative a and I got -3. I also know that q must be positive because the graph has been shifted upwards. Let's look at the next one. Again, we are asked to find the equation, and this time we are dealing with a hyperbola. So I write down the general equation y is a over x plus q. Because they haven't indicated otherwise, my horizontal asymptote appears to be the x-axis, so therefore q is 0, so I'm just going to omit that. And then to calculate the value of a, I'm going to substitute the given point in, and I'm going to say -1 is equal to a over 3. And I think the easiest is just to cross multiply, so a is -3. So the equation of this graph is y is equal to -3 over x. Again, the fact that a is negative is consistent with what my sketch, because I know if the hyperbola lies predominantly in the second and in the fourth quadrant, then I am dealing with a negative a value. Right. Now, I'm going to have a look at 2 more questions, one where I have to sketch the graph and one where I'm asked questions from a sketch. So let's have a look at the first question. Typically also in a test, we will be testing both skills, guys. So can you sketch the graphs and can you make interpretations from the sketch? We were told here, given the functions f of x equal to 2x squared minus 6 and g of x equal to minus 2x plus 6. They look very similar, but don't be fooled. The first is a parabola, the second is a straight line graph. And they are simply just asking us to draw f and g on the same system of axes. Right. So let's start with f. F is our parabola. What do we know about this parabola? Well, firstly, it is a smiley face parabola because the value of a is positive. Secondly, it has been vertically shifted down by 6 units, so I'm going to indicate that first. This is now rough. I'm not using a grid. So it's got a minimum turning point at minus 6. And I'm now going to calculate the y-intercept. So I'm going to say 2x squared minus 6 is equal to 0. So 2x squared is equal to 6. So x squared is equal to 3. So the x-intercepts are plus and minus the square root of 3. Now, I don't know exactly what that is, but I know it will be less than 2. So I'm just going to indicate it there. Negative root 3, 1, 2, and positive root 3. X-axis, y-axis, and let's clear some space over here and connect our parabola. The parabola is going to be quite flat because of the fact that A, okay, that's not the nicest parabola ever, but there it is anyway. Moving on to our straight line graph, which is g of x equal to minus 2x plus 6. Now, firstly, I know that this graph will have a y-intercept at plus 6. I'm going to use the dual intercept method. So I'm going to say minus 2x plus 6 is equal to 0. Minus 2x is therefore equal to minus 6. So x is equal to 3. I'm indicating 3 over there, connecting the dots. And that just won't do because I'm not even close. So let me use a line rather. Right, so then that's 6 and that is 3. And that looks correct because my graph is going, my line is going downhill from left to right, which is exactly what I expected because the graph had a negative gradient. Now, the next question that they are now asking us based on this graph is calculate the points of intersection between f and g. Now, if you guys looked at our graph, it looked like they definitely intersected each other on the one side. On the other side, if I'd carried on a little bit longer, they would have intersected each other. Very important, guys. Whenever we need points of intersection, we take the equations of the two graphs and we equate them. So I'm going to say 2x squared minus 6 equal to minus 2x plus 6. Right. So 2x squared plus 2x minus 12 is equal to 0. And I get a quadratic equation, which I very much expect, because as we said just now, it looked very much like there was 2 points of intersection. I can now divide this equation through by 2. X squared plus x minus 6 equal to 0. Factorize the trinomial and calculate the values of my points of intersection, or the x values rather. X is minus 3 and x is 2. Now, they want the coordinates of the points of intersection, so I need to go back, substitute back. It's easiest to substitute back into the line graph. So I'm going to substitute minus 3 back into the line graph. So I'm going to get minus 2 times minus 3, which is 6, plus 6, which is 12. So minus 3 goes with 12. And let's find out what 2 goes with. Minus 2 times 2 is minus 4, plus 6 is 2. So there I have my points of intersection. Right, what I want us to do now is I want us to move on to a question where the sketch is given to you. Right, so let's have a look at the next question. The next question says, f of x equal to 4 to the power x, that would be an exponential graph, right? And g of x equal to 4x squared plus q are sketched below. So let's have a look. There's our exponential graph. It's moving away from the asymptote. It is above the asymptote, and quite clearly the asymptote appears to be the x-axis. Then my quadratic function, I am clearly, guys, missing a minus here because it must be a typing error, because the graph is a non-smiley parabola. Absolutely, yes, there we have it. There's our minus that I was looking for. Plus q. Now plus q shifted the graph upwards. So they also tell us that the points A, which is 0 and 1, important to put them on your sketch, and the point B, which is 1 and 4, is given. So I've put that onto my sketch. Let's have a look at the first question. The first question asks me to determine the value of Q. It says determine, not calculate, because you can actually see it. If you guys have a look, the moment you fill in the point A, you can see that the point A is the turning point of the parabola, so therefore the value of Q must be 1, because the parabola turns where y is equal to 1. So I'm going to say the value of Q is 1, which now makes the equation of my parabola g of x equal to minus 4x squared plus 1. Right. Next question. Just putting in the minus there. The next question asks me to calculate the length of BC. Now remember, I know that B is the point, X is 1, Y is 4. Just filling in A as well. So what does BC represent? BC represents the difference in Y value from the exponential graph at x is equal to 1 to the parabola at x is equal to 1. Now, on the exponential graph, I know that when x is equal to 1, y is equal to 4. So what I now need to determine is, on my parabola, when x is equal to 1, what is the y value then? And I then need to determine the difference. So important, because of that perpendicular sign, I can assume that these two are directly under each other, or not assume, I know that. And I now know that C on the parabola is also x is equal to 1. I need to determine the y value. And I'm going to do that by substituting x equal to 1 into the equation of my parabola. So I'm going to say g of 1 is negative 4 times 1 squared plus 1. That gives me negative 4 plus 1, which is negative 3. So therefore, if the y value at B is 4 and the y value at C is minus 3, it means that there is a 7-unit difference. Look, 1, 2, 3, 4, and 1, 2, 3. So that is 7 units. Right, lovely question. Let's move on to the next one. Again, I'm just going to put everything that I've calculated to date onto my sketch. C I now know is 1 and negative 3. give the equation of f of x reflected about the x-axis. So what they are saying is f of x looks like this. What is the equation of its reflection about the x-axis, which will be something like that? Now, when I battle with reflections or when I forget, what I always do is I start with a point and I say, okay, if I had a point that I needed to reflect in the x-axis, let's say I had the point 2, 3. If I have to reflect the point 2, 3 in the x-axis, it still stays 2, right? But what happens to the y value? The y value becomes negative. So if my equation at the moment is y is equal to 4 to the power x, it will now become negative y is 4 to the power x. Now, we don't like a negative on the y side. We like to have y on its own. So what I'm going to do is I'm going to divide through by a minus and get y is equal to minus 4 to the power x. Right. Let's have a look at the next question. They then want to know from us, give the equation of f of x shifted vertically upwards by 1 unit. Now, f of x at the moment is 4 to the power x. What do you do to shift something up? You add a q. So if I want to shift it up by 1 unit, that will be 4 to the power x plus 1. If I wanted to shift it down by 3 units, that plus 1 would have been replaced with minus 3, and so on. The next question asks us to give the equation of the asymptote of f of x. Now, f of x is in the form 4 to the power x plus, and its q value is 0. Now, q value gives us the equation of the asymptote, so the equation of the asymptote must be y equals 0. So if the q value was, let's say, 7, then the equation of the asymptote would have been y is equal to 7. Right, next question asks us about ranges for f of x and g of x. Now, we spoke about domain and range right at the beginning of the lesson. Remember, the domain is the x values that our graph is drawn for. The range is the y values. So now let's talk about the y values. If I start off with my parabola is defined from y equal to 1 down to negative infinity. The parabola is not drawn at 2. Its highest value is 1. Its maximum turning point is 1. So I will write y an element of square bracket 1. I'm actually going to just do it the other way around so that it's a numerical order. Sorry, you guys. So basically, from negative infinity up to 1. So I'm going to say round bracket, negative infinity, and a square bracket for 1. That is for my range of f. That is my range of g, rather. That's my parabola. Then for the range of f, which is my exponential graph, the x-axis is an asymptote. So f gets closer and closer and closer and closer to the x-axis, but it never touches it. So therefore, it is defined only for positive y values. So y is an element of 0 with a round bracket, because the graph doesn't actually touch the asymptote, and it will go on to infinity. And remember that infinity always gets a round bracket. Grade 10s, I hope that you guys have learned from this lesson. Basics for graphs are not difficult. You do, however, just need to practice, practice, practice. And the best advice that I can give you, always have a mental picture of what you think a graph is about to look at. What a graph is meant to look like. From all of us here at Learn Extra, good luck. Keep working, and we'll see you next time.